Hello everyone! In this tutorial, we're going to create a pagination system in Java Swing using FlatLaf. We'll be loading customer data from a MySQL database and displaying it in a JTable. Paging is very important, especially when your application handles a large number of records. You don't want to load everything at once. It would slow down the app, and users don't want to scroll through thousands of rows either. Instead, we'll display just 50 records per page, for example, showing the most recent data first. Then, when the user wants to view more records, they can simply navigate through pages or search for what they need.
Alright, now let's get started. I've already created a project in IntelliJ, and in this video, I'll show you the code I've written. Let's start by looking at the pom.xml file. Here, I've added the dependencies that we'll need for this project. You can see my modal dialog library included here. Since we're using the snapshot version of this library, we also need to add the Maven snapshots repository. Next, we add the FlatLaf IntelliJ themes dependency, which allows our application to use a modern system look and feel. After that, we include the libraries we need for working with the database. For connection pooling, we're using Apache Commons dbcp2. This library manages database connections efficiently by reusing existing connections instead of creating a new one each time. This makes our application faster and more efficient. And finally, we add the MySQL connector J for the version I use 8.3.0. This is the official JDBC driver for MySQL, and it allows our Java application to communicate directly with the MySQL database.
So now, let's look at the mainframe. Here, I've created the table, the pagination, and the label for the total records. Next, I initialized the table and defined the columns. So we have column first name, last name, company, and more. So these columns should match the fields in the database. Then I set up the pagination using the Pagination class from the modal dialog library. In this example, I set the selected page to 1 and the page size to 50, but these values will be updated later when we load the data. And then we add the pagination component and label total record to the panel page. Now, let's run it. Here we have the empty table, and at the bottom we can see the pagination, which is set to show 50 pages as an example. Next, I'll show the connection class. This class is inside the connection package, and it's called database connection. In this class, I've defined some configuration for connecting to the database. We have the host, which is set to localhost. The port is set to 3306. For the database name, I used db-test. And finally, we set the user and the password. And now, back to the mainframe. Here, we connect to the database. We also wrap it in a try-catch block to handle any errors. Inside, we simply call databaseconnection.getInstance.connectToDatabase. So next, I'll show you the database that I created. Here, we have the database called db-test, and inside it, there's one table named customer. I'll just double-click to open it, and here we can see the customer data. This is only example data that I downloaded from the internet. In total, this table contains 1,000 records. So we can test this data by loading it into our application and displaying it with pagination. Before we write the code to load the customer data from the database, I want to show you how to change the default pagination to my custom pagination with animation. Let's run this first. As you can see, this is the default pagination, but I want to replace it with the animated version to make it look nicer and feels better to use. Here, go to my modal dialog GitHub repository and open the demo project. Inside the component package and the pagination package, we can see the paging animation class. We need to copy this class into our project. So first, I create a new package called Pagination. Then, I copy the class name. So create a new class with the same name. And copy all the code from this class. Now it's done, with no errors. At this point, we can use it simply by replacing pagination with pagination animation. Now we can run it again, and here we can see the new pagination with animation. Next, we're going to load the customer data from the database. But before that, we need to copy some code from the demo project. Go to the demo package, then into the sample package, and inside the CSV package. Here we need to copy two classes, response pageable and pageable. Let's start by copying the pageable class.
We can create it in Pagination package. Then we copy the response pageable class.
This is an abstract class, and it extends from pageable.
But in my case, I don't need it as an abstract class anymore, because I won't extend it. So I just remove the abstract keyword and use it directly. Next, we're going to create a class to store customer information as an object. For that, I'll create a new package named data, and inside this package, I'll add a new class called model customer. In this class, we'll define all the fields that exist in the customer table from our database.
First, we create the customer ID.
First name, last name, company, city, country, email, subscription date for the date we use from package java.sql. And the last one is website. Next, we generate the getter and setter methods for all these fields. Then we add a constructor to initialize the fields, so we can easily initialize all the fields when creating a new customer object. After that, we add a method to convert the customer data into a table row. This method will return an object array, and we call it toTableRow. It takes one parameter, the row number, and returns a new object array containing all the field values. So now we can use the toTableRow method to easily add customer data into the JTable. Next, we are going to create the customer service. So I go to the data package and create a new class called serviceCustomer. Inside this class, we create the method to select all data from the table customer. As we see, we already have this table in the database. This method will return a response pageable. This is the class we copied earlier from the demo project. For the data, we use a list of model customer. And we call the method getAll. This method takes one parameter, which is the page. And finally, we need to declare it with throws SQL exception so that we can handle database errors outside the method.
Next, create a variable named limit and set its value to 50.
This will define how many records we want to display per page. Before we can fetch data for pagination, we need to know the total number of customers in the table. To do this, we'll create a new method called getCount. Let's first write and test the SQL query directly in the database to get the total number of records. So to get all records, we use select with count function. Now run it. Here we see the result show 1,000 customers. Now copy this query into your Java code.
Here, we create a new variable to store the SQL query. Next, we implement the getCount method. Inside this method, first, create a connection object. This class comes from java.sql. Then, create a prepared statement. After that, use a result set to store the result of the query. Next, use a try finally block. Inside the finally block, make sure to close the prepared statement, result set, and connection. Now, initialize the connection object by calling databaseconnection.getInstance.createConnection. This line creates a new connection to our database. Next, we initialize the prepared statement and pass in our SQL query for counting records. After preparing the statement, we execute the query by calling p.executeQuery. This will run the SQL and return the result set. Next, we create a variable total and set it to 0. Then, we check if the result set has a value. This means if there is a row, we take the first column, which is the count of all customers, and assign it to our total variable. Finally, we return the total number of customers. Now, we can use this getCount method to get the total number of customer records from the database. This total value is very important because it will drive our pagination system. For example, if the method returns 1,000 records and we set our limit to 50, that means we will have 20 pages to display all the data. For calculating the total number of pages, we will implement that part later. Now, let's move on to the getAll method. First, we write the SQL query to select all columns from the customer table. Now run this query. Here the result is returns all customers from the table, but this is not what we want. We only need 50 records at a time. To fix this, we can use the SQL limit clause. For example, if I set the limit to 10 and run the query again, it now returns only 10 records. We can also specify the starting row. For example, if we write limit 110, the query will return 10 records starting from the 101st customer. But here's something important. In SQL, the starting index begins at 0, so we need to subtract 1 from our calculation. That means instead of using 100, we should use 99 as the starting value.
Now, we get 10 records and start from the row at 100. So we know we can use the select SQL with a limit clause to control how many records are returned each time. This is exactly what we need for pagination in our application. Now just copy this SQL query into our Java code so we can use it directly inside the getAll method. Just like we did with getCount, we now create a new variable to store this query. We'll name it getAll and then paste the SQL query that we copied. But instead of using fixed values for the starting row and the limit, we replace them with question mark placeholders. This way, we can pass the actual values later when we prepare and execute the statement. So now, inside the getAll method, the first step is to get the total number of customer records by calling the getCount method. Next, we calculate the total pages. For this, we use math.ceil and we take total divided by limit. This makes sure that if there are any remaining records, they will still be included on the last page. Then we calculate the start row. We take page minus 1 multiplied by the limit and wrap it with math.min along with the total value. This ensures that the starting row never goes beyond the total number of records. And next, we copy the code from the getCount method, but we need to change the prepared statement from getCount to getAll. Here, we also need to set the parameters, one for the start row and one for the limit. Next, instead of returning a single total value, we prepare a list of model customer. Then, we change the code to use a while loop so we can go through each row from the result set. Inside the loop, we get all the customer data, create a new model customer, initialize it with all the values, and then add it into the list.
Finally, we return a response pageable object. This needs the total, the page size, the limit, and the list of customers. And with that, our getAll method is now complete. So next, let's go back to the main form and write the code to load data into the table. First, I create a new method called loadData. And this method takes one parameter, the page number. Inside this method, we use a try-catch block because the getAll method has a throws exception. It returns the response pageable, so we create the response pageable object. For the data is list of model customer. But we need to create the service customer, so let's create that. And then initialize it after we connect to the database. Now we can call service.getAll method and pass the page parameter to get the specific page. The response pageable object now contains everything we need: the list of customer data, the total number of records, and the page size, just like we defined in the getAll method. Next, we'll use this data to update the label and display the total number of customer records.
Now we display all the customer data in the table. To add data to the table, we first get the default table model from our table. Since getModel returns an abstract table model, we need to cast it to default table model. Next, we clear all existing rows before adding new data. We can do this easily by calling setRowCount to 0 on the model. After clearing the table, we loop through the list of customers and add each record to the table one by one. We'll use a for each loop and call response.getData to get the customer list. Then we use the addRow method together with our toTableRow method from model customer. The toTableRow method takes a row number as a parameter, so we'll create a variable named row to keep track of it. To calculate the starting row number, we take page minus 1, multiply it by the limit, and then add 1. And then we increase the row number by using row++ to move to the next row for each customer record.
Now we can call the loadData method. Here, after connect to database and initializing the service customer, we call loadData. For the first page, we set as 1 to load the first page. Now we can run it. We can see that the table now displays 50 customer records. However, the pagination isn't updated yet. It still shows the default example with 50 pages. The total record label, on the other hand, correctly shows 1,000 customers. Next, we're going to update the pagination values. Inside the loadData method, we call pagination.setPageRange, and we pass in the selected page and the page size. We can get both of these values directly from the response pageable object.
Now let's run it again. Here we can see the pagination now shows 20 pages, which is correct based on our calculation. Next, we'll add an event to the pagination, so that when we change the page, it will automatically load new data. To do that, go to where we initialize the pagination. We call pagination.addChangeListener, and for the listener, we can use a lambda expression. Then call the loadData method and pass pagination.getSelectedPage as the parameter, so it loads the correct page each time we switch. Now let's run it again.
And that's it. Our pagination is working perfectly. Each time you switch pages, the table automatically updates with new customer records. Thanks for watching, and I'll see you in the next video.